This is part 3 of video on the solutions for the Fall 2013 AP Physics course test number 3. In problem number 12, which of the following scenarios is possible if a student finds that the acceleration of a cart is minus 3.5 meters per second squared in the x direction? It says the cart is located at the origin, traveling in the negative x direction. So it's traveling in the negative x direction and is slowing down. Now what we know is that we're looking for a cart whose acceleration is pointed in the negative x direction. This says that he's traveling in this direction, v, and it says it's slowing down, which means that ax is in that direction. So that's not possible. Next one. Cart is located 3.5 meters but is traveling in the positive direction, moving this away, at constant speed. Well, constant direction, constant speed means that the acceleration is 0. That's not possible. The cart is located at 2.5 meters, traveling in the positive x direction. So there's the velocity. And it's slowing down, which means the acceleration is in this direction. Aha, that matches what we were told. Okay, so that one is a possibility. Now the bonus problems. Bonus problems were a review of material from the previous test. Write the following numbers in engineering notation using the correct number of scientific figures. Okay, 1, 2, 3. This would be 25.3 times 10 to the minus 3. Over here, we have the 0 is not significant. 1, 2, 3. We have 33.21 times 10 to the third. Then the next problem is a problem that involves some trig. And we're asking you to do some vectors with the trig. So here we have some distance b and some distance a on a triangle. A is an adjacent side, so it's 32.0 times the adjacent side. We use the cosine, and we find that length is 29.5. And b is the opposite, so 32.0, opposite side you use sine, s closer to o. You get 12.5. So that's the lengths, and then to make the vector, we have to give it any signs. This one is going in the negative direction, so that is minus 29.5 I hat. And this one is going down in the negative y, so minus 12.5 j hat. So there's the vector in Cartesian form. And let's see what the last problem I think is. We have a little tricky problem, like similar to homework, of an elevator cab. And it says that this cab in a New York hotel picks up a passenger in the lobby. The cab accelerates from rest to 1.16 meters per second squared for 5 seconds, and then travels at a constant speed for 4 seconds before decelerating at a magnitude of 1.16 meters per second squared for 5 seconds to return to rest. That's a lot of information. Let's draw a picture. There's some v meters per second. We know that it accelerates at constant speed, so it's constant slope, and it gets up to some speed, which we're not given, call it Vm for maximum. Then it flattens out, and then it goes back down. It took 5 seconds to get up to this speed. It took 4 seconds that moved at constant speed, which would make that 9. And then this time right here, that would be 14 seconds. All of those are in seconds. The slope here is 1.16 meters per second squared. The slope there is minus 1.16 meters per second squared. All right, how far did the elevator travel during this trip? Well, delta x, which is the displacement, is the area under a VT graph. So looking at that, I see that delta x is equal to 1/2 times 5 seconds times Vm plus 4 seconds times Vm. That's the rectangle, plus another triangle, 1/2 5 seconds times Vm. And if I put all that together, I get 9 seconds times Vm, whatever the maximum speed is. But I got to find the maximum speed. However, from the fact that I have a slope here, I have the equation of a straight line. So Vm is the velocity at 5 seconds. Vm is equal to 1.16 meters per second squared. That's the slope, times 5 seconds plus the y offset, but the y offset was 0. That's just applying y equal mx plus b for a straight line. So this gives me 5.8 meters per second. So delta x is then 9 seconds times 5.8 meters per second, and it says that you traveled 52.2 meters. Part B. What was the average velocity during the trip? Well, this is just again checking to make sure that you know basic definitions. V average, by definition, is the displacement over the change in time. We just found the displacement, 52.2 meters, and we did that over a total time of 14 seconds. So that's 3.73 meters per second. Again, the main thing about the test, and this one was testing basic ideas like motion graphs. Do you understand fits? And do you understand basic concepts and definitions? You got to know the definitions if you plan to use them throughout the course. So we're testing those very, very heavily. And that's it for this test. See you on another video.